Hello and welcome to this video where we'll go into scaling of resources inside of Azure. So we'll go and talk about how to scale in and scale out. So vertical and horizontal scaling. So what do these terms mean? And how about the pricing models in Azure? And how does it compare with when you have it on premise? So then you have something called capital expenditure compared to in Azure, it's pay as you go. So let's move on to the keynote. So here, scaling of resources and pricing model in Azure. As you can see here, vertical scaling, you drag up the computer. So the computer becomes stronger basically. While horizontal scaling, you add more computers or you add more compute in order to do more stuffs. We will go into different scenarios where you'll need vertical scaling compared to horizontal scaling. So the need for scalability, let's talk about that first. So on-premise, we have physical servers, and then the workload is increasing. What will happen? We need to buy more hardware. And when we buy hardware, we require a large upfront cost. This is called CapEx, or capital expenditure. So you pay upfront a lot of money and then you get your hardware. And then you need to, and afterwards, when everything is set up and it works well, then the usage cost is lower. So this is mostly capital expenditure when you buy hardware. However, this is not flexible and hard to manage. And why is it not flexible in terms of, for example, suddenly you have a lot of workload and then you need to have more servers. And then after a while, you don't have so much workload. So then it's hard to, we'll return these computers, we'll return all these servers back. And then suddenly when the workload comes up again, we need to buy those again. So it's not as convenient as you may notice. So it's not easy to scale it. And when the workload drops, we're stuck with the cost because we have already paid for our hardware. So we have already bought this physical service. So when it drops, sucks for us. We need to pay still. Okay, so an example of horizontal scalability in Azure. Let's look at that. So you have a super awesome web app and the workload increases. Let me move myself. I can move myself here. So the workload increases in Black Friday. We have a lot of users. We cannot just leave it as it is. So if we don't scale up, we don't scale out, we don't have horizontal scaling, then it means that the web page will be very slow. We will lose customers to our competitors, and that is not allowed. Then we'll lose a lot of money. So we add more VMs, virtual machines, automatically to handle the load. And the users don't realize anything. They just see the web page as usual. The super awesome web page is working. And then Black Friday is over. People go back to their usual shopping habits. So we remove these VMs when traffic becomes normal. So during a short amount of time, when the workload has increased, we pay more money. And then afterwards, when the workload goes down, we decrease the number of VMs and we pay less money. So we pay based on how much the workload is. That is the idea. So this is called horizontal scaling. So this is very important. So horizontal scaling, same as scaling out. So we're scaling out, we're adding more machines of the same size, basically. So an example of vertical scalability in Azure. So let's say we have a data analytics job that will serve a dashboard. So we have a lot of data that comes in. So large batch of sales data to process. So when you have a large batch of sales data, it doesn't help to have several computers, right? It helps if your computer is stronger, or it could help with several computers as well. However, let's say for simplicity's sake, let's think like one computer that becomes much stronger. So you have more CPUs, you have more RAM, so that you can process this large data. So you add more compute on, for example, a Databricks cluster. So the Databricks you can use to do a large amount of computations to do data analytics. And then when the job is done, you scale back down so that you don't pay as much. So you pay more during the time when you're processing this large batch of sales data. Afterwards, you scale back down. So here we're talking about scaling up and down. That is vertical scalability. While horizontal scalability was scaling in and out. Okay? So notice the differences. So this is called vertical scaling, right? Up and down. For example, let's look at virtual machines and the different scaling types. So we have scaling up and down. So this is the vertical scaling, right? And vertical scaling, basically your virtual machine, when you're scaling down, it becomes weaker, right? And when you're scaling up, it becomes stronger. So it's bigger and bigger. So bigger in terms of more memory, more CPUs, etc. So resize your VM basically. So RAM, CPU, etc. And scaling in and out is horizontal scaling. Here's basically you have same size of your VM and you just add more machines to do parallel works. So horizontal scaling is this. So you add and decrease instances. So let's go into the pricing model and the CapEx versus OpEx. So I mentioned pay-as-you-go, and pay-as-you-go is more in the category of OpEx, so operational expenditure. Capital expenditure is what you pay upfront, right? So pricing model, we have CapEx. It's when you have on-premise, it's CapEx. You pay mostly CapEx. You still have OpEx in terms of you need to maintain your machines. You need to have people to do different types of maintenance, to maintain your data service. So then you still have OpEx as well. But you pay for the data centers is mostly CapEx. So in terms of CapEx, what more do you have when you have on-premise? You have your buildings, the facilities, they cost a lot. You have hardware, they cost a lot. You have licenses as well. So, for example, if you have Windows machines, then you need to buy Windows, the OS, all other softwares you need to pay as well. Those are licenses. So you have high upfront fixed cost. So this is CapEx. But you own your assets. This is important. So the hardware is yours. You own them. You own the buildings, or you maybe rent the buildings, but basically you own the assets in CapEx. While in OpEx, you pay monthly for Azure VM, storage, networking, etc. So here is you pay as you go. When you need it, you pay. Or when you need it, you add up the cost and then you pay monthly for different resources. So this is operational expenditure. Note that as simplicity, we divide it as this, but in on-premise, you also have operational costs. So expenses based on operations. So based on what you do, you pay, right? And this gives high flexibility because when we're having less workload, we can scale down. We use less resources. We pay less. When we need more workload, when we have more workload, we increase the resources, we pay more. So it's more flexibility. So the pay-as-you-go model, you have this. So it's based on operations, you pay monthly. And here is pay-as-you-go, you rent services. And when you do cloud adoption, so if you go from on-premise to cloud, or more hybrid solutions, or going cloud direct, or a lift and shift to fully cloud, you shift the pricing model, you shift the capital expenditures into operational expenditure. So this is an important image to have in mind. So you shift the expenditure, the pricing model. Okay, so simplified cost chart of the pricing models. So you have cost and you have time. So the upfront costs, this is the capital expenditure. When you're buying your service, you pay this much. And when you're scaling, you increase the cost, right? It's suddenly like you buy one more server and then it costs this much more. And when it's time to scale again, so this is the scaling cost, then it costs this much. So this is capital expenditure. Let's look at operational expenditure, or pay as you go. So this is very simplified, that I made it linear. More real is that it fluctuates. So it fluctuates, but the trend might be similar to a linear trend like this. So sometimes you have more, sometimes you have less, so it fluctuates more. So this is the pay-as-you-go model. So when you're using your resources over time, you're using it over long time, then the cost accumulates. So note that, for example, you have this much work, the workload can be covered by this much of your service. So then your cost will stay in this place if you're using on-premise for simplicity. But for pay-as-you-go model in cloud, it will keep increasing. So there is a risk that pay-as-you-go using cloud is more expensive than your on-premise solution. When you say it's cost efficient in cloud, then it depends, because using cloud, and if you're using the resources without planning for them and without planning the costs, then it could cost a lot. You need to be able to monitor the cost as well. There's cost monitoring in Azure, and you need to plan your budget. So if workload is stable and your hardware is not underused, then the CapEx model won't infer much cost as opposed to OpEx. So this is an important thing to keep in mind. Yes, and in this video, you have seen some theory about scaling of resources and pricing model in Azure. So we have scaling as in vertical scaling, scaling up and down. We have horizontal scaling in and out. And then we looked into two pricing models, the operational expenditure and the capital expenditure, and a little bit of the difference of them, and in cloud versus on-premise, which type of expenditures we have, and looked into pricing chart. So I hope that this gave you some intuition about the scaling of resources in Azure and pricing models. So thank you, and see you in the next video. Bye.